My dear friends, welcome back to Bee Spice. In this session, we'll discuss about layers of protection analysis, that is LOPA. The agenda for this session is what is LOPA? Okay. Then we'll discuss about the details of the layers of protection. What are the various details, layers of protection? Then the important one, LOPA methodology, the various methodology involved in arriving and doing, carrying out the LOPA. Okay, friends. So what is LOPA? LOPA is a process of evaluating the effectiveness of independent protection layer. Very simple. So what form? In reducing the likelihood or severity of an undesirable event. Very simple, isn't it? Yes. So alternatively, we can call it as it's a risk assessment process used to establish an approximation of risk for a particular scenario through assessment of threat and consequences pairs. So this is a little bit definition. Okay. So each controlling measures like engineering, administrative, all these are assessed to determine whether they meet the individual protection layer criteria. Okay. To be independent, a layer of protection should be capable of preventing an unsafe scenario from progressing, regardless of the initiating event or the performance of another layer of protection. Point is to be an independent, okay, a layer of protection shall be capable of preventing an unsafe scenario. That's it, friends. Okay. Safety is provided by layers of protection. Okay. This layer starts with, safety, then the process control, then extend to the manual, automatic prevention layers, and continue to with layers to mitigate the consequence of an event. Don't worry, we'll be dealing with each and everything in the subsequent slides. So just get to know what is what here in this session, in this, what do you call this slide. Okay. Now, this is a very important one, friends. As you can see here, we have a BPCS. What is that? Basic Process Control System. Then you have a SIS, you have a passive protection layer, and yeah, here active, here passive, and the final one is emergency. So the point here is, as you can see here, all these three gentlemen, this all, preventing the safety hazard. Okay. But here it's all mitigation. It's incident already occurred. Okay. This is a mitigating thing. Okay. That's a point. So we'll see one by one. The first layer is the basic process control system. And the system itself provides significant safety through proper design of process control, right? Okay, this itself provides significant safety through process and proper design of process control, right? The next layer of protection is also provided by the basic process control system through operators such as automated shutdown routine in the process control system with operator intervention here. Okay, you can see here. So to shut down the processor, right? So these are the two things within the BPCS. We are talking about layer of protection. Okay. The next layer is the safety instrumented system. This here, this guy. Okay, a safety system independent of the process control system. Separate sensors, logic, valves, all these. Okay, friends. So now all of these are designed to prevent safety related event or hazardous event from occurring, right? Okay. Now we go back. If the safety related event occurs, okay, here occurs, then there are additional layers designed to mitigate the impact. So that we are going to see here. The next layer is the active protection layer, which has two parts. Okay, one is the automation part, which is fire and gas system. Other is the manual part, which is the relief system. Okay, right, fire and gas and the relief. So the fire and gas guy, what he will do, he will reduce the consequent severity or hazardous event by isolating the leak and ignition source. Agreed? Yes. Then the relief valve or rupture disc are designed to provide relief point that prevents a rupture, loss spill, or other uncontrolled release that can cause an explosion of fire. Okay, friends? I hope this is clear. Right. Now we go to the passive protection layer. The next layer is a passive protection layer. What is that? Which consists of a dike, or passive barrier that serves to contain a fire, channel the energy of explosion in a direction that will minimize the spread of damage. So that's a passive protection. Okay. So the final one is the plant and emergency response, wherein if a large safety event occurs from this layer, response in a way that it minimizes the ongoing damage, injury or loss of life, like evacuation plan, firefighting, all these. Of course, the guys, the intermediate engineers who work in a plant understand this, but freshers is a bit hard. Anything if you want to have a separate session or whatever you have any query, you can always write back to me. Okay, friends. Right. So this is about the details of the layers of protection. Now we talk about the summary. Okay. So one is the process design. Okay. Then second is the basic process control system. Then third, the operator and alarm responses. All these actually, right? Here. Then the safety instrument system. Then the relief valve, rupture disc. Then the fire and gas system. Then containment, DAC vessel. All these. Then the emergency response. So this is the fire protection summary, layer of protection summary. Okay, friends. Now we go to the main thing. Of course, before going, I just want to touch upon a bit. See, ESD, emergency shutdown system, which we discussed previously, right? The specification, all this, right? Yes. So it's a preventative layers of protection. Preventative layers of protection. They act to prevent a hazardous event like chemical release, fire, or explosion from occurring. They act to prevent, this is typo error, not former, from occurring. So they act to prevent a hazardous event. FGS is a mitigating because the purpose is to reduce the consequence severity of such as an event when it occurs. So that is a difference. Just remember, friends. Okay. When a flammable gas, toxic gas, smoke, flame, or heat is detected, then FGS will respond by enunciating audible, visual alarms and initiating the water deluge, fire suppression, of course, or sometimes process shut. So this is how, it works. So in the event of gas leak, FGS can prevent it from becoming a fire or explosion by isolating the leak or the ignition sources. I hope now layers of protection is clear. Okay, friends? Right. Now, very, 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 very important methodology. Just pay attention, friends. If you have any challenge, you can, listen 2, 3 times so that, it will be easy to follow. I'm going to give you and explain you nicely with an example, with the recent, the HAZOP, which I did, and with the LOPA, which I did. All these I'm going to explain very, of course, briefly. This is not going to be, classroom session. But anyway, whatever is available, the 30 minutes, 40 minutes, I'm going to give you some insights. See, friends, again, the idea is, see, HAZOP is not, important. I mean, like meaning it was driven by the process team, right? So we support for our ICA. But whereas LOPA, it's our involvement is more actually. And that's the point. Okay. So the intent is you try to get the, the concepts, the gist from this. Then you can apply. Oh, that's the point, friends. Okay. Right. I try to give as much as possible. Okay. LOPA starts with the data developed in the HAZOP study. Very important. And one more point, if you have not watched the HAZOP video, you can watch and then you come here. Otherwise, you will not, you will feel like lost. Okay, that's right. So LOPA starts with the data developed in the HAZOP study and accounts for each identified HAZOP by documenting the initiating cause, protection layer, okay, all those things. So the amount of total risk reduction can be determined and the need for more reduction area analyzed. If an additional risk reduction is required and if it is provided in the form of a SIF, LOPA methodology allows the determination of appropriate cell for the function. This is all just to get to know what is what, friends. Now we go to the methodology. Okay. So, friends, select a SIF identifier from the P&ID. Okay. Right. So here, develop an impact scenario based on the HAZOP workshop records. That's why I told HAZOP workshop. So we need to develop an impact scenario. What is that impact scenario? So the consequences in the HAZOP record are listed as impact event. Very simple. Okay. The consequences listed in HAZOP as or is the impact events here. So that is a point. For each impact, evaluate the consequence like HSC, assets, all these. personal. All these we need to come out of this. So now, before going to the ICL, I want to stop this and go to a HAZOP sheet so that it will be easy for you to follow. Okay, friends. So this is the HAZOP which I did recently, friends. Okay. So just pay attention. Just an example. Just look and feel. Don't get into too much. Just look and feel. You see the LOPA scenario. You see the category, the personal, right? Personal, assets, environment, all those, right? Yes. Then you have the severity, right? Yes. Then the time, frequency per year, okay? All these there. Then you have the SIF, final element. Then the initiating event description and the frequency per year. And then comes the frequency modifier, like conditional modifier, enabling condition, demand per year, demand frequency, then the IPL, independent protection layer, all these, then the PFD, then the, total PFD, okay. Then here you have all these, the, what do you call, the PFD value and the RRF. RRF is risk reduction factor. So it's nothing but the inverse of PFD, okay. So here you can see 150 means it's a SIL2. So this is just a typical example, friends. Okay. So now I hope this is clear somewhat for you. It's clear. Now I again go back to my, the slide. Then I'll come back here whenever needed. Okay. I think with that example, you got some insights. Okay. Now we'll go to now we know the SIF identified and HAZOP scenario also we identified. Okay. Now, first thing, identify initiating causes and quantify likelihood. We call it as an ICM. Identify initiating causes and quantify likelihood. Identify initiating causes, I, C, and likelihood. Okay, right. So determine the initiating cause for each impact event, meaning all of the initiating cause of the hazard determined in the hazard. Okay. LOPA team shall quantify the initiating cause likelihood for each initiating cause. Typical initiating cause and associated likelihood of failure used for LOPA analysis in the chemical industry are presented. See, for example, since I worked in a petrochemical, so I am going to present you the chemical scenario. And of course, you also have similar to this based on your projects. Okay. So here, this is the one, friends. Identify initiating causes and quantify likelihood ICL. Can you see here? Initiating event. These all things. Frequency you can see here. All these, right? Pressure vessel, residual failure, piping residual failure, piping leak. So against each initiating event, the frequency, meaning the event per year is given here. So you can go through it and you can apply this. Okay. I'm not going through everything. Okay. Right, friends. Now, we have the ICL already, right? Okay. Now, we need to identify the identify and quantify the conditional modifier, that is CM. Okay. So, after considering ICL, LOPA team may apply frequency modifier. Okay. So, what are the frequency modifier? Three category. One is the ignition probability. Second is the occupancy factor. Third is the time at risk. Remember this, very important. So, now I'll go to the ignition probability. Ignition probability relates to the hazardous scenario being analyzed as PI. One means material release above auto ignition. PI, 0.1 means release heavy liquid. If a volatile liquid, you put 0.2. Flammable liquid, you put 0.3. So these things we need to keep it in mind, friends. Very important for the conditional modifier. Okay. This is ignition. Then now we have occupancy factor. To be a health and safety hazard scenario, personnel need to be in that area that could be impacted by the hazard. Okay. So credit should be taken for the time that personnel are not in the area if the hazard may result in health and safety impact. We call it this terminology is a little bit odd for the freshers, but the credit should be taken. This is the credit, the value actually we should take while doing the calculation. So credit should be taken for the time that personnel are not in that area. Okay, right. FP, PP, the factor PP, occupancy factor is only valid if a person presence is random with respect to the hazard causes. If the hazard occurs only at the startup and personnel are always at the startup, then occupancy factor is 1. Correct, friends? Obvious, right? Yes. Occupancy factor is not used for environment and asset scenario. This is only for the personnel. Okay, right? I told you, no, personnel, environment, asset, right? Yes. So this is only for personnel occupancy factor and time at risk. Okay, for systems that are not continuously operated, initiating cost likelihood is adjusted to reflect the fraction of the time the hazard is present. So that is also we need to take care. For systems that are not continuously operated, okay, the initiating cost likelihood is adjusted to reflect the fraction of the time, fraction of the item that hazard is present. Okay, what time that hazard was present. So time at risk, what is that? How we can calculate? It's simple. Determined by dividing the time that the process is in operation by the total time, 1 calendar per year. So now we know what do you call the PI, right? Ignition probability, and we know the occupancy factor, and we know the time at risk. So we are done with conditional modifier. So we are done with ICL, we are done with conditional modifier. We call it as a frequency modifier, different terms. Okay, friends? Okay. Now, very important. A typical hazard list, all existing and operational hazards safeguards, including that that may not meet the criteria to be accounted as IPL. Okay. A typical hazard list, all existing operational safeguard, including many that do not meet the criteria to be accounted as far as accounted for as IPL. Okay. So an assessment of each safeguard will be taken by the LOPA team to determine the amount of risk reduction provided by each safeguard, its dependability, its independence from other safeguards. So very, very important point, friends. Just pay attention. Those identified as IPL, if we call it as IPL, if we quantify as IPL, then it should be quantified during the LOPA study. Okay. Okay. There is some criteria. That's the point I'm coming to this. LOPA team will consider only protection layer meeting the following criteria. What is that? Specifically designed to prevent or mitigate the consequence of potential scenario. Specifically designed. That is the point. Then truly independent of other protection layer, meaning there are no common cause mode failure that deactivate 2 or more protection layer. So specifically designed, truly independent. Then dependable. It can be counted on to do what was intended. It should be dependable. Okay. Then designed so that it can be audited to facilitate regular validation of the protective function, proof testing, maintenance of the safety function. Okay. All these. So 4 items, remember, to qualify as IPL, specifically designed, truly independent, dependable, and designed to be audited. Okay. Right, friends. Now comes the main part. Okay, in a nutshell, only those protection layer meeting the requirement of availability, specificity, independence, dependability, and auditability will be classified as IPL. As simple as that. Okay, friends. Right. Other assumptions now. Okay. Other assumptions. Okay. What is that other assumption? Relief valve can be considered as IPL. Remember, friends, when we are attending this LOPA methodology, we need to remember this. That's why I told you, just get the gist of it. Relief valve can be considered IPL, provided if the relief system was sized for all reasonable failure of process control, and completely mitigates the hazard scenario under consideration. I hope this is clear. Then, another point, when there are 2 independent relief devices, each 100% size for the hazard scenario, then credit should be taken for an additional layer of protection. Friends, are you following? Okay. When 2 independent device, relief device, each should be sized for the hazardous scenario. Okay. Then the credit should be taken for an additional layer of protection. Okay. A tight shut-off against reverse flow is required. Check valve are notoriously unreliable, and hence single check valve cannot be considered as a IPL. Okay. So that is the point we need to remember. These are the 3 things here. Relief valve, 2 independent relief device, and the check valves. Okay. Now, We'll start with the basic process. The basic process control system. See, everywhere we have to, meet some criteria. That's what I'm telling. We talked about relief device, all this, right? So now we need to focus on the BPCSM. So BPCSM will have the following rule associated with their use as IPL. What are all those? If BPCS control is the initiating cause, if you remember the layer of protection, the first one, yeah, that BPCS, right? So if BPCS is the initiating cause, alarm generated by that control loop cannot be counted when considering operator response to an alarm as a layer of protection. That is the point. If a BPSCS control system is the initiating cause, okay, alarm generated by that control loop cannot be counted when considering operator response to an alarm as a layer of protection. Okay, that is the point. Okay, friends, it's odd, but yeah, this is what. Okay, failure of mode of the final element to be safe state. Okay, the following condition must be met before operator response to an alarm will be claimed as an IPL. This gentleman. Okay. So what are all those? Alarm is independent of the cause. Operator is always present and available at the alarm point, meaning the control room is continuously manned. Alarm gives a clear indication of the hazard and will be given high priority on the control room console. The big, the audible or something, a very big. So have given high priority. Okay. Operator has time to diagnose and take corrective action within 10 minutes. So these are the things we need to meet. If we need to keep this operator response to alarm as a IPL. Remember, friends, very important. Okay. Now, the following condition must be met before operator response will be claimed as an IPL. Oh, and additionally also, okay. So those, in addition to what we discussed, operator is trained in the response associated with the alarm state and response steps are identified in safe operating limits of the operating manual. Risk reduction for operator response to alarm was only counted as a single protection layer. Okay, these things also we need to keep it in mind. Okay, now probability of failure on demand for IPM. Okay, now we have the standard values. Actually, I'm going to present that also to you. Like what we discussed, right? The earlier we have some standard values, right, for the chemical plant, right? So for that, like that, I have the PFD for each item. This is the probability of failure of demand. Dike bund. This is the one. PFD value. Underground drainage. This is the one. And yeah, this is for the vent, overpressure, prevention of overpressure, fireproofing. All these are just read out, friends. Use it. Yeah, you'll be having this. Don't worry. You'll be having a chart like this. These are the other things. Blast wall, inherently safe design, flame, detonation arrestor, relief wall, rupture disc, basic process control system, all these actually. For example, here can be credited if as an IPL, if not associated with the initiating event being considered. So then rupture disk, relief wall, all these, SIL1, SIL2, all these, okay? These are the value, a typical value when we use it. When we use it, you can apply, right? Right. So now, very important. Now, how to calculate now we have seen all these, right? We have seen all the BPCS, relief wall, all these. Now we need to calculate the PFD values, all we have seen, right? So now we need to calculate the intermediate event likelihood. So what is this intermediate event likelihood? See, this is the likely of occurrence of the event taking into consideration of all the IPL and conditional modifier. Okay, how to calculate this? Intermediate event likelihood is calculated by multiplying the initiating likelihood. If you remember the ICL, right? By the PFD of the protection layer and the mitigation layer. All these friends. Okay, so IEL is equal to ICL. So intermediate event likelihood is equal to ICL. What is that ICL? Initiating cause likelihood. Then the PFDs, all these probability of failure demand for each IPL. It depends on how many IPLs you are going to take. And also this one, the occupancy factor, all these, right? Conditional modifier, PI for the probability of ignition, PP for the conditional modifier for the probability of person being present, and the PT or conditional modifier for the probability of time at risk. All these, this is how we need to calculate the intermediate event likelihood. So if intermediate event likelihood is less than the corporate criteria of event of the severity level, additional IPL are not required actually. Additional PLs are not required. That is very important actually. You have the corporate matrix, friends. Okay. So if that value is less than the corporate criteria for events, then no IPL is required. That is a point. Okay. Now we calculate the LOPA to determine the required sale. So how we are calculating? Using the numerical values identified in the preceding step. So preceding step. Okay. Preceding means how we are going to do now. Okay. So a set of three LOPA calculation is performed for each initiating cause. Okay. If the LOPA ratio for people, you remember people, environment, asset, right? This greater than one, greater than or equal to one. Very, very important, friends. Just remember, if the LOPA ratio for people, how to calculate all this, we'll see. Don't worry. Okay, I'll show you that. But again, see, you are not doing manually. You have your automated sheet actually. Every LOPA, you have a sheet. For example, in my case, I did using one, Excellentia. This was provided by Exida, Excellentia software, wherein we can do this LOPA. Okay. So all have the calculation inside. So you don't have to worry. The point is you need to remember the concepts. Okay. If the LOPA ratio for the people, environment, and asset is greater than or equal to 1, the existing protection layer are advocate for the scenario. So don't have to worry, do anything, just leave it less than or equal to 1. But on the contrary, when the other side, sorry, not contrary, on the other side, if the LOPA ratio is less than 1, then LOPA ratio will be used to determine the safety integrity requirement of the existing additional loop according to the table presented. Okay, what is this table here? This is very important, friends. This is what I was highlighting. Okay, so here, if LOPA ratio is within this 1 by multiplied by 10 is to 1 until 9.9999 into 10 is to 1, that is less than 10, risk reduction factor, RRF, this is nothing but inverse of the probability of failure on demand. RRF is nothing but 1 by PFD. Okay. So if it is less than 1 means don't have, less than 10 means no need to worry actually. Okay. This is the LOPA ratio 1 actually. Less than or equal to 1. And RRF reduction, risk reduction factor less than 10, no need to worry. Okay. So now SIL 1. What is that? Between 10 to 100. If your RRF value is 10 to 100, then SIL 1. 101 to 1000, SIL 2. 1001 to 10,000, SIL 3. Then more than 10,000, then SIL 4. Of course, it is not acceptable. We need to redo the design. Okay. So this is about the methodology, friends. I hope this is clear. Now what I will do, I go back to the sheet again so that you will get some more insights. Okay. Just recollect whatever the concepts we have covered so far. Can you see here, friends? I have taken the LOPA scenario, right? Loss of oxygen supply to the combustion chamber leading to the flame out and continuing the biogas with the potential auto ignition of biogas and uncontrolled combustion explosion, okay, to the inlet ducting and back filter housing, impact to the personal damage. All these are, I have taken a very big case. Anyway, just for example, okay. So you just remember this tabulation, friends, the contents. LOPA scenario is there, right? Category here, personal, okay? And the severity, S5. So basically, friends, the severity, there is one, matrix actually. So in that case, what is severity 1? See, severity 1 is slight damage. Again, this is, I'm just telling from my experience, you will have your project own matrix actually, the classification. So here it's a personal, right? So personal here 1 means not affecting much actually. For example, yeah, if it is 5 means it is too much actually, very severe, major effect actually, right? See, for example, here we are talking about personal, right? So personal means severity 5 means catastrophic. Catastrophic means multiple fatalities or permanent total disabilities. If it is severity 4 means single fatality or permanent total disability. Severity 3 means critical, major injury, and severity 2 means minor injury, 1 is negligible. So like that we need to classify. This is for personal. In case for, for assets, severity 1 means slight damage. I mean, like, disruption to the operation less than US 10,000 cost. And severity 2 means minor damage, brief description, cost less than 100K USD. Then severity 3 means local damage, I mean partial damage. Okay, so like 500K. Then major severity 4 means major, so that is around 10 million, yeah, 1 million, like that, friends. If it goes beyond that, then it is 5 severity, like that. Okay, then you have the SIF right here. And what is the frequency? This is also there. So this is about the LOPA scenario. Then you have the SIF, all the tag, right? Then we talk about the initiating event, right? This is the one, ICL, right? We talked about ICL. Yeah, this is the one, electrical mechanical failure of biogas superheater. Yeah, you see, and the frequency per year. Okay. Then we have the conditional modifier. So wherein we know occupancy, all this, right? So here, this, since the personal occupancy is not credited due to personal exposure in wide area of the facility. Okay. Operational personal exposure in wide area facility. Okay. So the person is there actually, because that is why here occupancy not credited. Why? Due to personal exposure in wide area of the facility. Okay. So then you have your probability. This is one. Every year it occurs. Then all these actually, like for example, yeah, demand frequency. So you have this frequency modifier. Then you have this IPL. This is the independent layer of protection. I told you, no? Yeah, this is the one. See, biogas superheater, blower one electrical failure will initiate the power burner tripper by closing this valve. So, credit not taken due to the same final element with SIF in demand. So, here credit not taken. But the point is, this guy, this electrical failure will initiate the burner trip by closing this valve. So, this is one of the IP, okay? Independent layer of protection. You got it, friends? Okay. Now, the total PFD, see, we have considered only one. So the PFD value is 1 for this actually, and total PFD is 1. Now you have to see the LOPA. What is the result here? You can see here the PFD 6.67 E, all these, some calculation is there, and this is what we got it. So then we need to come out with the RRF. RRF is nothing but the inverse of the PFD. So here we got the RRF of 150. If you remember the sheet, the tabulation, so 150 means SIL2. You got it, friends? Very good, right? Yes. So that's how we do this, friends. Okay. I hope this is clear. Maybe I can take you, I'll take you some other example also. Yeah. You can see here, this is the safeguard. Higher temperature of the BGHS, biogas superheater, impact to the superheater steam outlet temperature leading to the exceedance of the design temperature. Okay. That is the one. So thereby, impact to the personnel. This is also personnel, severity 5. Then you have your SIF. And what is this? This is your initiating event. What is this initiating event? Manually or manual wall are inadvertently closed. Okay. So this is infrequent. It's not going to happen every time. So they put it as only 0.01. Likewise, you have all these values, right? Then you can see here, it meets the RR of 90 actually. Here actually nothing. The IPL, they are not taken anything. So the value of RRF is 90. So that means it is a SIL 1. Okay. Then maybe we can take this example. This is also nice, right? Yes. Low flow to the biogas leading to the flame out and continuing the biogas with the potential auto ignition of the biogas and uncontrolled combustion leading to the degradation to the inlet ducting and back filter housing and impact the personal and damage. You can see here, this is your safeguard. And what is the initiating event? Low pressure condition. Then you have the occupancy factor here. One person is always, occupancy not credited because the person is all exposure due to personal exposure and wide area of the facility. Okay. Then you have your, what is this? This is IPL. So basically, we have a 2 out of 2. A flame mode will activate the burner tree by closing this valve. Okay. And finally, if you see here, it's a 300. The RRF is 300. PFD is this one. RRF is 300. That means it is SIL2. Okay. This all for the personal, friends. Huh? This all for personal. Maybe I can take you some other example here. Let me see. If not, nothing can be done. All are personal only. I think, yeah, I don't have anything else. Yeah. Anyway, the point is not only personal, we have to, take aside environment, all these actually. And likewise, we need to quantify, friends. So this is the, gist about this. Yeah, maybe let me do one more thing. I'll just stop it. We'll see we can have some more thing. LOPA. Yeah. Yeah, maybe here I can share you something. Yes. I'll go back again. Go back again. I share you something here. Where is this? Yeah. Sorry, not here. I think I missed out. Download. Sorry, desktop. Yeah, where is that? Uh, sorry, friends. Yeah, LOPA here. Yes. So here, this one. Okay. Yeah. I hope it is clear, right? Yeah, you can see here. This is all personal. Again, this is also personal. Yeah, this is also personal actually. Yeah, I just want to share something for the assets, but unfortunately it's not there. Anyway, this is how it has to be, friends. Huh? It has to be same fund actually, right? So I hope you got some, insights. So I'll go back to the sheet. Yeah. So this is how we need to calculate, friends. So again, the intent is to give some insights on the how the LOPA is, carried out. What are all the methodology involved? So yeah, this is how we need to come out. If any questions or want to have, a better example, you can, write to us. We can support you, friends. So yeah, that's it. Then. Before actually, what I'm planning, I'm going to talk about the SIL actually. So before going to SIL, I thought it appropriate to talk about IEC 5061508 and also 61511. So we'll see in the IEC 61508 video. Thanks a lot again for watching, and yeah, keep supporting, and yeah, if possible, share with your friends. Because friends, your support is important. Support not only subscribing, you need to watch, you need to watch and show your support by pressing the thumbs up button. Okay, so see, I'm putting some effort, for the benefit of our friends. So what I expect is nothing but watching, right? Watching, subscribing, all these. That's it, friends. Thanks a lot, friends. See you. Bye bye.